Okay. So good evening, everyone. I am Venugopal Mahajan. This is live session for week 3 for the course Scheduling Techniques in Projects. The course instructor is Professor J. Maheswari. So this will be covering week three's content, which the deadline of submission is already over. So the contents we will be covering is information driven scheduling, DSM basics, DSM formation, partitioning, and some iteration modeling basics. Is my screen visible to all?
Yes,
Uh,
much.
yeah. So this is an interactive session. So as much as we can discuss, it would be beneficial for uh, both sides, for everyone. So first question to you guys: did you know about this technique, this DSM metrics, DSM before coming to this course, or used it on site?
From my side, I didn't know, but anyway, I told you I'm an IT engineer rather than a civil.
Yes, sir.
I have used PERT and CPM very extensively, and a Gantt chart, of course. That is my bread and butter for
Yeah.
any project, but nothing, not on DSM.
Okay. Uh, yeah. Anybody who has applied this on? Uh, Mayur, I can't hear you clearly.
Uh, I'm sorry. So actually, in Primavera, yes, and method is also not right.
Uh, can you please
Primavera
uh,
physics.
can you please be a little clear?
Yes, actually, in the Primavera physics, this method is also not used because I'm also working in Primavera.
Okay. So you're telling that there is something like this in Primavera?
Yes, sir.
Okay. Yeah, it might be. I mean, I only used Primavera till PDM, not for DSM. I will have to try it. Thank you. So coming to the question here, and this is kind of a reverse question. You don't get it like this, but this is for basically for the theory part. Determine the sequence of activities for the given DSM. What you have been given here is there are 5 activities, and there is a box. There are some X marks. So from the convention, you already know that this is the convention. This means that if this is the X marks, B gives information to A, right? So determine the sequence of activities for the given DSM. One thing would be to start by partitioning it and knowing the sequence, right? This is what has been already done, but we will do it in reverse manner. Like we know what gives information to what, so let's try to plot it in form of what we have studied so far, and that is basically activity of node network on node network. So let's try it. B gives information to A, then we have got C gives information to A, uh, C gives information to B, and C gives information to E. D gives information to B, D gives information to C, and D gives information to E, and E gives information to B. It kind of looks like a, I mean, lot of relationships, lot of activities following each other. I mean,
Right.
giving information. So, are you saying something? Okay. So, giving information can be considered as a finish start relationship. Like B is finishing and giving some information that, oh, B is finished. So,
Right.
let's proceed with A. So, now let's try to bring it in some sequence. So can we do it? I mean, it looks like uh, quite varied. We can't determine what's the starting or what's the end point till we remove one of the arrows. So let's say I
See,
removed D gives information to C.
see, D doesn't get any information at all, right? So why can't that be the starting?
Oh, right. D is not getting any information, right? So, okay, D is the first activity. What about next? See, D is done. So, we can have a C now, right?
If D is done, yeah, we can.
Yeah. C, I mean, this
Be-
arrow is gone now.
exactly, because C doesn't have, other than D, there is nothing, right?
Yeah.
Yeah.
Similarly, after C, we can have E,
Yes, because E
then
requires, yeah, correct.
then B, then A.
Then B.
Now let's try to plot all the arrows. Uh, we have got D
Sir, why
gives.
not we place B before E?
We can place B before E. I mean, from what I look, from where I look, it looks like E is giving information to B.
Yeah. E. See, you have to wait for E to happen, right? Because
So let's try to plot it. I mean, this is not some numerical or something that would come directly. Um, okay.
Sure, sure. Okay, sir.
So D is giving information to B. D is giving information to C, and D is giving information to E. Similarly, C is giving information to A. C is giving information to B, and C is giving information to E. And similarly, uh, for which activity? Yeah, E. E is giving information to B, and B is giving information to A. So if this was a simple CPM, you would have said that if if B is supposed to happen only after E and E is supposed to happen only after C, why do you need this arrow? C, uh, I mean C to B, C giving information to B. Because there might be the case that C is giving some information, but we are expecting it in some other manner. In CPM, so many relationships go missing. I mean, we are just linking it logically.
so
In
you are saying that um, C can give a particular type of information to E and the particular another information piece of information to B, right?
Yeah,
Okay. Okay. So that finish to start of C to E and E to B doesn't capture this unless you put another arrow from
yeah.
C to B. Okay.
I mean, if if C1 is giving if C is giving parameter P1 to E, and
Ah,
it is also generating P2 as output, which is required for working on B.
yeah.
So this kind of gives you a sense that okay, there is some kind of information flow, parameters flowing from one point to other. In this case, activities and parameters. So if you were supposed to make a CPM network or find the duration of these activities, it would have been quite easier, right? You have a start point, you have a finish point. These are kind of in series. You just add the duration and find out.
Yeah.
So now let's move to making a matrix for, I mean, uh, giving it in a sequence. So for sequencing, we know that we have to partition the matrix, right? Or am I using the wrong term? This was the term, right? Partitioning.
Right. Yeah.
Yeah. So what we do is we look for, first of all, we look for empty rows and columns. Okay,
Yeah.
empty rows and columns. So in this case, you can see that D is an empty row. Empty row
Yes.
means D can come at
The
the
beginning.
beginning,
Yeah.
right?
Yeah.
So once we have moved D to the beginning, let's remove it from our discussion further and look at the other activities. I hope this is clear to everybody what we are doing. We did the same thing in case of Fulkerson's rule also. Once we number one event, we would forego all the relationships going from that event and move on to whichever event doesn't have any incoming, right?
Yeah.
So similarly, here we determined that okay, D can be executed first. So crossed off D. Now moving on, is there any activity with empty columns, empty rows? Yeah, it is C.
C. C.
C. So that brings C to the second. Now, see, here in this case, we could have moved on to anything like one empty row, one empty column, or first we check for empty rows, or first we check for empty columns, or anything alternative. So, okay, we have removed D also, no? So, let's try with empty columns. Which of the following has empty column? I guess A has empty column.
A is empty. Yeah.
Yeah. So for empty column, we are going to move it at the end. Now coming to the next, we can see that if you go by empty column logic, we have got B.
Now, can we move empty column before completing the empty rows?
Before
Pardon,
completing,
sir.
yeah,
Sir, can we continue? Sir, can we continue for the empty columns before completing the empty rows? Or first we have to complete all the empty rows. After that only we can go to empty column.
okay. See, the logic here is that, I mean, it is kind of
After D
a,
and C, sir,
yeah,
like after D and C,
yeah, you can do
after
it.
D and C, E is the empty row.
Yeah.
So we should do E first, E row, or we should go for the column.
You can go anywhere you like. I mean, till you have not gone into active block, this doesn't
So
matter
the sequence will be
because
changed in the line.
no,
So
it
the
won't.
sequence will be changed then because D and C are the first and second activity.
Yeah.
So correspondingly, E will be the third or A will be the third.
See, we looked out for empty column, right? If it is empty row, we bring it to the beginning. Okay, we bring it uh, towards this
We
end.
have started with. So we have okay.
And if it is empty column, we
Yeah.
move it
Yes, sir.
towards this end, na bottom end.
Um,
Like we
Right,
didn't,
yes, sir.
we placed A at the fifth point, not at the third point, right? Are you getting it?
Okay, okay.
Okay, we will solve partitioning again and again for this exercise because basically in case of DSM we have got a lot of inputs
sir.
and outputs. So we need to determine what is going to be the sequence, how to execute these. Okay, so now coming back to our matrix, looking for empty rows. If you look for empty rows, it would be E, or if you look for empty column, it would be B, right? So, okay, first if I look for empty row, we have got E, and now only B is remaining, right? So let's have B here.
Yeah.
Once we have this order fixed, yeah,
Sir, sir, may I ask you one question?
yeah, yeah,
When we are saying that there is a empty column or empty row, when there is a no cross mark, isn't it?
yeah.
But when we are discussing now, E is empty row wise and column wise, but there are two cross marks at the down and in upper side of this diagonal. So how it will be empty column or empty row?
Okay, I'll I'll repeat it. Looking for, if you look at A here, this is the column for A,
Yes,
right?
yes, sir.
Right. So this is an empty column. You don't need to check for both
Yes.
conditions. It is row or column.
Yeah.
So you determine that A has empty column.
Yes.
So that kind of goes to the last. We have 1, 2, 3, 4, 5. So that
Yes.
becomes your 5. Now
Hmm. Hmm.
once you have crossed off B and C, I mean B giving information to A, C giving information to A, for the purpose of partitioning, it doesn't matter to us because the remaining contenders are these only, right? We
Yes,
already
sir.
placed
Yes,
A
sir.
at the last.
Yes, sir.
So if you just come to this block, now you can say that okay, again looking for empty column, B as empty column.
Hmm. Yes.
So
Yes, sir.
B becomes your fourth activity. I mean empty column, so put it last. Yeah,
Hmm.
and empty row put at start. Now,
Sir,
now here,
in that case, sir, B will come after A or
see we
B
have
will come before A.
like 1, 2, 3, 4, 5. You already placed A at the last, na? I mean last placed is already booked. So now the remaining box is this only,
Yes, yes,
right? So B
yes,
comes
yes,
second
yes.
last now. I mean remaining B here. In this sense again, E would become your third. Similarly, coming to here, C would become your second, and D would become your first. Even going backwards, we are getting the same, right? Initially, we mixed both of these, two rows and then went to columns, and this time we just went by column logic, and we are getting the same. Okay, so now let's put the X marks. I mean, we have sequenced them, but the relationship is missing from this DSM, right? So let's put the cross marks. D D gives information to B, C, and E. D gives information to B, C, and E. Similarly, C gives information to A, B, E. E gives information to B only. B gives information to A. Right? Have I put all the cross marks? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, all the cross marks are there. So what you see in this case is when your logic is that gives information to, I mean X gives information to Y. In this case, if you are getting a lower diagonal matrix, you see that upper diagonal is empty, right?
Yeah. Yeah.
So it happens when we have got everything in sequence, like there are no loops here. I mean all the arrows are forward moving, there is no arrow coming backwards, right?
Correct. Yeah.
Yeah, and this is the sequence kind of. So when you have got activities in sequence and there are no loops, we won't find any arrow above the diagonal. So
Arrow won't move from right to left, right? That's what you are saying.
yeah, in this case, I mean arrow can move obviously. After coming to this point, let B can give information to D also.
Hmm.
We will see that it happens.
Acha.
So
Okay. No, but see,
yeah,
you always not only explain the concept but also give the pure English interpretation, right? So, what is the necessity of getting a lower triangular matrix? How does it help us?
okay. So how does this help us? Now I will bring you to okay. Sir, can we carry this question for the next example?
Sure. Please, don't let me interrupt here.
Yeah.
Just ask.
No, I mean we can visualize it better there.
Yeah, I'm sure. Yeah, because I always liked your way of giving interpretation. Try to understand what it means
Yeah.
rather than just putting a number. That's the reason. Yeah.
Yes, sir. So we will see it in next. Okay. So we have got here in this case, you can see that we have got activities in sequence with all the arrows moving forward only. In that case, we are getting a lower diagonal matrix. So if this were some kind of a CPM problem that we could solve directly without going into DSM and all, with all the methods that we have already studied, that that did not take in care of if cycles or loops are present, we will get a lower diagonal matrix and we can solve via that manner. So even if initially your matrix can have elements on the, like in this case, it can have on the upper diagonal also, above the diagonal, but once you partition it, you will get to know the sequence and get to know if it is lower matrix, lower diagonal or not. So I hope you got the importance of partitioning the matrix. So coming to this question, this will kind of bring in what happens when there are a lot of arrows and how do we do it. So you all can see the figure on your screen, right? So what is this? I mean, what kind of figure is this? This doesn't look like a CPM or PDM to me.
Yeah.
So what is this? Anybody who would try to guess or venture a guess here? What is this figure?
This is a figure with the interdependency.
Yeah, interdependencies, showing interdependencies. So this is basically a graph structure. I mean, there are nodes at the activities, and there are edges showing the relationship, directional edges. I mean, uh, for here, let's say A and B are the nodes. So for these nodes, we have a directional relationship, like A giving information to B. So you got to understand that the graph structure, but there is a lot of information missing. I mean, we know the interdependencies, but what is causing the interdependency, we don't see. Okay, now can you see some loops here? Or I would just bring your focus on D and G. D is giving information to G and G is giving information to D,
Right.
right?
Yeah.
So if we had to do it in CPM or PDM, it would have been quite, I guess, I mean, we don't have formulas to solve this, right? Either
Yes.
either we'll be going forward or coming backwards. Like we start calculating some values here, 8, 10, then going back again because it follows the same logic. 10, now what happens? I mean, 10 would be again here only, na? It's a cycle, not meant to be solved by those methods which are not, they are not for cycles or loops. So is the situation what we see on the field? Does this arrive on, I mean, do you see these kind of situation on site?
Yes, sir, it can be.
Yes,
Uh,
sir. Yes, sir.
uh,
It is happening during the concealed work.
sir, can you
Sir,
please repeat your
sir,
example?
wherever it is a cyclic work, like
Sir,
it is a continuous but cyclic work, so there will be the dependency.
cyclic work, can you give an example?
Mm, the like for the construction of cooling tower, sir,
Yeah,
natural draft cooling tower,
yes.
shell we are constructing, sir. It is a continuous work and it is a cyclic work.
Uh,
Every lift will be constructed.
okay,
So
yeah,
in that lift, sir, there are four processes.
yes.
First, we have to tie the reinforcement. Secondly, we have to do the shuttering. Third, we have to lift the jump form. Fourth, we have to do the concreting. Okay, sir.
Yeah,
So all the activities are related to each other. Once the reinforcement is tied, shuttering gang will be
yeah,
uh, that we can say parallelly. We can also do that work.
yes.
If, if shuttering is delayed, the concreting will also be delayed. The manpower may be uh, utilized according to that.
Yes, sir. Sir, I get that point, but my question is, do we see something cyclic here? I guess what you are meaning is that after four, we again have to repeat one, right?
Yes, sir.
But what is happening is that if you perform one for first lift, then second activity for first lift, then third activity for first lift, and fourth activity for first lift, you are not going to do first activity for the first lift, right? What you are doing is you are actually doing first activity for the second lift now.
Yes, sir.
So this is not cyclic now. I mean, you are not getting back, you are moving forward actually.
Sir, there is a good example of cyclic work.
Yeah.
So there is a good example of cyclic work
Yes.
that when concealed plumbing work during the concealed plumbing work and plastering work.
Okay. Concealed
Con-
plumbing.
Concealed plumbing work is there.
Yes.
Before plumbing, we have to plaster the wall surface.
Yes.
Then we have to make the groove. Then insert the pipe, fix it, and again we require to plaster it, patch up it before going to next work. So plastering work is repetitive. Unless first we require to plaster, then we have to insert the pipe, and again we have to make it clear so that plaster will be matching with each other.
Okay,
Then
sir.
and then only we can go for the tiling work. So there is a sequential operation between plastering and plumbing.
Uh, Sir, you also gave the right word here, sequential. Now, may I ask you in that, does this happen that you go on doing the same thing? I mean, you said that okay, we do the plastering once, then we make the groove, then we put the plumbing, right? Then again we go to plastering, right?
Yes, sir.
So does this happen that after going to plastering, you again go for the groove at the same location? I mean, you move on to the next, right?
Yeah. After plastering, then
Yes.
we carry forward the tiling work.
Yeah. So you see that what actually you have given an example is that you are doing uh, you are not completely repeating that activity. What you are doing is that whatever change you made, you will repair it.
Can I say so? Can
Yeah.
I say something?
Yes. Yes.
Actually, sir, currently in a bullet project, so many drawings are actual drawings and so
Um,
many
Mayur,
MP drawings are.
Mayur,
Yes,
you
sir.
need to go on mute, yeah.
Uh,
Mayur, please.
Hello?
Mayur, it's quite difficult to listen what you are telling. Uh,
Sir, actually, right now I'm in traveling mode.
yeah.
That's why my voice is too much disturbing.
Yeah.
But sir, so many drawings are in revision mode. Just like some drawings structure is revised. Some minor changing in plan or minor changing in
Mayur, I'm
typography.
sorry to
So
interrupt,
any
but
structural
I mean, it's quite impossible to hear what you're saying. Can you please message it? I mean, I don't usually prefer messages, I prefer mics, but I can't hear him
yes,
clearly.
I will
Anybody
send you a
else?
message.
Anybody else who got what he was saying? Okay, I'll come back to this example. So what is happening is that whatever change you made in for in the second and third stage, you are just repairing that and tiling and then moving on. So and there is, I mean, it is not happening like that. That after plumbing, you again go to the
So one
plaster
more
at the
process
same.
we can check it, sir.
Yeah. Yes. So kind of this brings
Sir, one
the,
more thing we can check it out, sir.
yeah,
Like in the case of backfilling site, sir,
yes,
we do the compaction.
yes,
We do the compaction for that. We like at the time of backfilling, once compaction is done, we assume that our test result is okay. If the test result is not okay, again we have to do the compaction.
okay, yeah, that can be an
If the
example.
desired result is not coming for
Yeah,
the compaction,
okay, yeah, that can be an example. Yeah, so from Mayur, we have got his message that in structural and drawing revised because of minor change in site condition or any of this, we use DSM. Yeah, we will see this in case of design. Yeah, there is some cyclicity in there. And inspection is carried out in at all stage. So we can take that. Okay, yeah. Inspection. So in case where we have got lot of rework or even some rework, we can say that what is happening in inspection. I mean, this will be similar to the backfilling. This will be similar to backfilling or any drawings. We guess, I guess. So what is happening is that you do some work X, then there is activity Y, which is your inspection. Now this gives you information that if it is okay or not okay. So in case of not okay, you again go to activity X, do it again it's inspected. If it's okay, you move on, not okay, you come back. So there is some cycle here, right? If you were to determine the duration of this, let's say X takes 3 days and Y take 1 day. So this cycle could be completed in 4 days only. 3 days for X and 1 day for Y. And if it's okay, we'll move on. But if it's not okay, you will again take 3 days to do it. Right? 3 plus 1 plus not okay. So that means you have to repeat X plus repeat Y and again move on. So when you are scheduling for this, if there is some activity A, then X, Y, then B. So if you were to calculate the total time required for this, you would kind of miss what is happening here, right? I mean, wait a minute. Where did my cursor go? Yeah. So to determine the time of this block, you don't know how much it will take. I mean, just by looking at these calculations, right? So I hope you got an idea of. Mm, did you get an idea of cyclicity? I mean, cycles can be
Yes, sir.
present.
Yes, sir.
Okay. So coming back to this question, now you can say that okay, there are 8 nodes A, B, C, D, E, F, G, H. So there must be 8 activities counting the relationships. So all the edges actually are the relationships here, right? They will be the cross marks in our DSM. So let's try to make the DSM. Okay, I'll just be writing it in order. Now let's see. A. A is giving information to E and B, right? These two arrows. A gives information to, let me change it to a darker color. A gives information to B and A gives information to E, right? Similarly, coming to activity B, B is giving information to C, only C, right? B is giving information to C. For C, C is giving information to D. For D, D is giving information to A, B, E, and G, right?
Yeah, yes, sir. Yeah.
Okay. Now coming to E, E is giving information to B. E is giving information to B. For coming to
Yeah.
F, F gives information to C and G. Then coming to G, G is giving information to D and H.
D and H, yeah.
Yeah, D and H, and H is giving information
No, nothing. To E.
to
To
E.
E.
So you can see that there are a lot of loops happening. I mean, so can you guys count the cycles?
TG is one cycle that's
Yeah.
involving two.
Uh,
Then
okay, sir, let me interrupt. Uh, why do we want to know the cycles? Or why do we want to know the number of loops or what loops are there? What is the importance? I mean, we already discussed this part, right? I mean, if there is some loop coming, so that is potentially a black hole for us. We don't know what is going to happen, what will happen if we don't take it in consideration, right? If there is some
yes.
loop coming in our planning, we will, I mean, this is kind of a place where we can get lost. So that's why we
For
need to,
making the assumption.
yeah, yeah, right. I mean, if we have to cross the loop, we have to make some assumption or have some tier, break the chain somewhere. So for that, it is necessary that we know what the loops are. So what is the best way? I mean, can we just look at the DSM or the graph and find out the loops?
I think maybe it's easier to look at visually, right?
Yeah.
First, because it's not too many activities.
Yeah. So what is happening is that in case of only 8 activities, I mean 8 also, it will become difficult if we go and pinpoint everything. So it is difficult to find out the loops, and in DSM it's quite difficult to visualize right now. I mean, we don't have any partitioning done, we don't have things in order. So we will need something or some kind of algorithm that can be done by a computer to help us determine. And in case of civil, it's quite easy to get hundreds of activities, 200, 300. So let's try to find the loops in this case. I mean, as sir said, first DG, right? DG is one loop. Then any other any other loop can we see?
Mm,
B gives information to C, C gives information to D, and D gives information to B, right?
yeah. And
Uh, yeah, and
H,
I
if
heard
you
B.
start from H, HEBDGH,
Yeah,
that is HEBD. That's one
H
loop.
E B.
BD.
No, but
D.
after B, where can we go?
No, HEB. Okay, no, sorry.
Yeah,
Okay.
these are directional
Sir,
arrows.
No,
CFGD.
HEB. No, no, HEBCDG. Yeah.
C,
Okay, H E B
C
C
D G
D and then
G
G and then H.
G H.
Okay,
Yeah.
H E B
C
C
D
D
G
G
H. Yeah.
H. Yeah, and one more thing I was hearing around C and F, right?
uh, CFGD.
C F G D. Any other loop?
ABCD.
A B C D and A. Okay, any other? So you can see that even finding visually when there is a lot of parameter exchange happening, it can be
Correct.
quite difficult.
Absolutely. Yeah. Yeah.
So knowing which loop to break, we have to look for this. So we'll be looking it. Now how we actually read this is that, okay, DG. So uh, DG is one loop of cycle 2, right? I mean, of 2 activities only, right? I mean, in numerical you would be asked, so it would be DG will be counting as 2, BCD 3, right? If you are asked that which is the biggest cycle. So biggest cycle here we found HEBCDG, right? 1 2 3 4 5 6 of 6. Yeah. So these are potential questions that were also there in assignments. Now you saw that if you are given a graphical representation like nodes and their edges, you can make it a DSM and move on. I mean, forming a DSM is easy, but how to actually do it on site, or how can you do it? So this question deals with that part. For the given DMMs between activities and parameters, prepare the activity DSM, partition the matrix, and determine the active block. So my first question is, what is a DMM? What is a DMM? Anybody? Okay. So DMM here stands for domain mapping matrix. What we have here is that these are the activities and these are the parameters. Are you following me till here?
Yeah, yeah. Please, yeah.
Yeah. So uh, let's say you want to make the relationship between activities. I mean, uh, what are their interdependencies? So if you go and ask some guy who is performing activity B that are you related to activity D or activity E, it might be that something gets missing or you are not getting the full idea, right? You will just get a cross mark. Is it dependent on B or C? Just a cross mark. What is happening here is that for activity A, we determine that activity gives P2 and P7. For activity B, B gives P3 and P6. This thing we can determine, right? In the list of these 7 parameters, C is not giving anything. D gives P4, E gives P1, and E gives P5. Now, this is the output DMM, right? So now if they're giving these parameters, somebody must be using them, right? So now inputs, for the person who is executing A, you can definitely ask na, that, okay, which parameter do you require? So it'd be like, okay, I require P3, P5. These are the inputs. B will say P1 and P7. So similarly, you can get an input DMM. Now, how to make a DSM out of this? So for making the DSM, let's start giving some names to our X marks. A gives P2 and P7. Now if A is giving P2, who is needing P2? C, right? A gave P2 and C needs P2. So that means A gives P2 to C. You guys followed till here? What is happening and why is it happening? Any
So
doubt
what
on
is
that?
the exact relationship? Yes, sir. What is the exact relationship between upper output DMM and lower input DMM?
Uh,
What is meaning of drawing these two problem cases?
okay. Uh, sir, think of this as the data sheet you give on site. I mean, uh, you go to the person. I mean, you just give this paper on site and ask them that whatever outputs you are giving, you mark the outputs, and whatever inputs you require, you mark the inputs. See, initially, like if there is some relationship between A and E, it might not be that clear, but whatever they are producing and whatever they are needing, I mean, if you go one level down in case of parameters, so for activity A, the person knows that, okay, my output is P2 and P7, and to give this output, I will need P3 and P5.
Okay, okay, okay. Like
So,
that, like that.
yeah,
Oh, okay, okay. So by A, he is utilizing P3 and P5 resources to have an output of P2 and P7,
Yes.
isn't it?
Yeah, exactly.
And similarly for B maybe person or maybe machine,
Yeah.
it is consuming P1 and P7 items and producing P3 and P6 items.
Yes, definitely.
Okay, sir. Okay, sir. Okay, got it.
Okay. So let's start putting this in the DSM. A gives P2, P2 is used by C. A gives P7, P7 is needed by B. Right? Now for the next B gives P3, P3 for A. Then B gives P6, P6 for C and E. Right? I mean, two different activities can require two different inputs, right? Can give multiple input, can take multiple outputs, right? So P6 for C and E. Similarly, coming to C is not giving something, but C requires P2, P4, and P6. We'll see it later. Coming to activity D, uh, okay, okay, it might happen that we might miss something. Let me let me change it. I mean, in this direction, I feel that we might be missing some arrows. We'll go parameter by parameter, okay? Uh, P1, E gives P1, and P1 is required by B, right? So 1 here, P2, A gives to B, P3, B gives to A, P4, D gives to C and E. Uh, P5, E gives to A, E gives to A. Then P6, B gives to C and E, B gives to C and E, and P7, A gives to B. Have we written right? I mean the numbers. I missed P. Did you guys follow till here?
P7 is
Yeah,
wrong actually.
yeah. P7, A produces P7 used by C, right?
Yeah, P7. Okay, A gives P7 and B uses P7.
Yes.
So 7.
Yeah.
Okay. So now we'll just put the X marks here and get the DSM we are used to looking.
Actually, I fail to understand the correlation between input and output. How it is correlating.
Uh, okay, so this correlation. Okay, sir, we will discuss this in the next activity, definitely.
Because it is very much confusing.
Yeah,
P1 and P1 and
so,
it is.
okay. It might be confusing because we are just using some random things, na? A, B, C, D, E, P1, P2, P3.
If you
Uh,
can mention some activity, it would be.
yeah, definitely. Definitely, we will do the exercise next. So, this is the DSM you are getting, and it is also asking you to partition it. Partitioning we saw. I'll try to repeat the exercise. I mean, we can see D as empty row. Uh,
And so D goes first, and
okay, so let me take it to another page. I will just take the photo and okay, so we'll try to determine it here. D goes first, that we saw.
yeah,
D is going first. Then for the next, we
we
can,
can say C goes last.
yeah, C goes last. C goes last. Then, is there anything that we can do?
No, all the rows and columns are nothing is empty in A, B, and E.
Okay, so A, B, and E come somewhere here, and we don't know what is going to happen with these. So this becomes our active block that we have to take care of. I mean, D and C we know, and A, B, E we have to determine what is going to happen, right?
Yeah,
So this
yeah.
is our active block. Uh, so now coming to the activity, I mean, where we can determine what to do. I mean, activities and parameters. So we'll be talking in terms of let's design a RCC beam. How many of you guys are not? I mean, how many of you guys are familiar with this? I mean, designing an RCC beam. Just basic terms.
Familiar.
Yeah, please feel free to add. How do you design it?
First, we have to consider the supporting arrangement,
Okay,
then the loading condition, dead load, live load, and
okay.
seismic load.
So let me keep on writing. Okay, supports and supports, right?
Yes.
Uh,
Then loading conditions.
Loads. Okay, loads you talked about dead load and live load, right?
Wind load, anything beneath under
Okay, we'll just move on with two. Anything else?
that material properties.
Material properties. Okay,
Then we have to analyze.
then
Analysis.
okay,
Analysis.
analysis.
And design parameters.
Design parameters. Anything else?
Minimum specification depth, if any.
Okay, so that can be covered under design parameters, right? And for earthquake load, I mean, yeah. So we have got wind load, earthquake load, and then for minimum, we'll take care in design parameters, right? Is there anything else that you can think of?
Bar bending details.
Okay, BBS. I mean, calculating the reinforcement, right?
Yes, sir. Yes, sir.
Okay, reinforcement calculation was not here, so I wrote that. Anything else?
Sometimes there is a dimension restriction. We can
Okay, that
consider up to 500 or 300 as per site
okay.
condition. Then we have to restrict on that.
So there is dimension restriction. Restriction. Yeah. Anything else?
Sir, one thing more, sir.
Yeah.
The input from the design of support, size
Okay.
of support, like the column inputs. What is the size of column?
Okay. Size of columns.
Input has to be for that also to mention the width and depth of the beam accordingly.
Okay. Anything? I mean, you can see that in case of design, you can think of so many things that you have to take care of. So many things that, oh, if you designed a beam of 600 mm and you don't have that scope, you can only have beam depth till 550. You will have to revise it, right? I mean, so many things going on at the same time, so many parameters to take care of. I'm just repeating so many, and we will see why. Now, let's come to the relationships. End support, it depends on this, right? Your size of columns or your input you are getting, right?
Right.
Your dead load, you will say ki, uh, how actually I have how I have designed. I mean, what dimensions I have picked. it will determine my dead load, and from that dead load I would include it into analysis. Then from analysis I'll check with design parameters. If design parameters are missing, I will I'll check for dimension restriction. If dimension restriction is kind of disturbed, I will again change the dimensions, right? So let me bring dimensions here. So I will change the dimensions. If I change the dimensions, my dead load will change. My dead load will change, so my analysis will change. You can see a cycle here. I mean, can you see that there are like a loop happening because some things or because something is changing whatever is coming next.
Yeah.
Yes, sir. Yes, sir.
Okay,
Clearly.
so let's try to break it into broad categories so that we can see activities and parameters happening. Okay, so from this, let's have one category of load calculations. One category of okay, load, then another of analysis, like bending moment we check, right, in case of beam mostly. Then let's have
Serious.
material and dimensions. I mean, finalizing this thing, and our design check. I guess we can cover whatever list we have made into these four categories, these four major categories, right? Or should we have anything else? I mean, and support we can take it in design check also, material dimensions also, loads calculation, material properties we have got. These four look fine to me. Okay, so you have to perform four activities, four broad activities here. You have to calculate the loads, you have to analyze it, then you have to also determine the material to be used, material properties and dimensions of the beam, and you have to check if the design is okay or not, right? I mean, are you happy, are you satisfied with these four broad categories?
Sir, result will be schedule, bar bending schedule. So it should
uh,
be there as it is a completing activity.
okay, so it can happen na, that in material and dimensions, once you are finalizing it, you give the dimensions of everything. I mean, you give
Yeah,
the
yeah.
depth of beam,
Okay.
width of beam, finalize its reinforcement, right?
Right, right, right. Okay, okay.
Yeah. So these four activities. Now let's work on what parameters are they taking in, are they giving. Okay. So uh, load calculations, you will need dead load, live load. Live load is fixed. I mean, you already determined what is the purpose. Dead load depends on the materials and dimensions, right? Then you have to use this in can you see this flow? I mean, from dimension you are determining the dead load. You assumed something, you determined the dead load, you used it for load calculation, you perform load calculations, and now you will do the analysis. After analysis, if it's all okay, you will go to design check. If design is checked, it's done. If not, you will go back to material and dimensions and change it. I mean, a broad flow looks like this.
Yeah, more they are more interconnected, and loops will be more there.
Yeah. So so you guys can see that my drawing is very childish. I mean, same as my writing. Uh, so you can see that A is giving information to B for analysis. Uh, from B, we have got D directly to design check. From C, material and dimensions, we are determining A. From uh, yeah, from C we have that only, right? And from D, we will be varying the dimensions here, right? You can go on putting the arrows here, no issues, no worries. I mean, whatever interrelationships are here, but I am limiting it right now, right here, just to show you the relationships that we were discussing, activities and parameters, the terms we were talking in DMM. Okay, so this becomes our activity. Now we have one parameter, size of beam. So this size of beam will be used by load calculation, and after material and dimension we'll be getting this size of beam. So if size of beam is your parameter, you can see it being as an input and output, right? Can you see this? I mean, for activity A, this P1 is input, and for activity C, this P1 is output.
Yes.
You can, I mean, hopefully now you can get a link of what was happening in the DMM.
Yes, sir. Yes,
Now
sir.
it's getting clear. Actually, earlier for the nomenclature, it is a bit confusing.
Yeah. So it might happen, I mean, it will happen that there are a lot of parameter exchange happening, uh, a lot more of activities. So how to make this DSM with the help of parameters you saw, and now I will give you one additional example here. I mean, we will move a little forward from this. So you got a loop here, right? I mean, you can see the loop. A gives information to B, B gives information to D, D gives information to C, and C again gives information to A, right?
Yeah.
Yeah.
Yes,
So
sir.
if this is a loop and you want to break it, what will you do? In this case, you will say that, let's suppose, while determining the dimensions itself initially, I mean, I would start the dead load calculations with some assumption in my mind, right? We have some thumb rules that, okay, uh, we can use this size, we can use that side, whatever is it. But if you made this assumption right, this initial assumption of size of beam was more or less accurate, we can do it right with experience or not. I mean, if you are just designing a beam for a house and you have designed hundreds of houses, you know that if it's a 12 feet, uh, I mean 12 feet beam, then if its length is 12 feet, then its depth would more or less be 30 centimeters, right? Thumb rules. So if you make this P1, if you assume this P1 such a way that the loop that is happening, the repetition, if the design fails, it doesn't happen, right? If your design doesn't fail, there won't be any loop, right?
Yes. Yeah.
Yes,
So
sir. Yes, sir.
yeah, so what you are doing is that you determine something, I mean some connection in the loop, such that if you cut it, the loop doesn't exist, so that you can move on like CPM, PDM. And but the thing is that you should know where to cut. You should have some prior information, or you should have some additional information, right? So if D giving information to C, this arrow goes missing, I mean, I shouldn't. This cross becomes tick. We don't have a loop now, and we can move on, right? So you you kind of now know how to plot the DSM. I mean, plotting it, sequencing it, finding the cycles, and determining the tier mark. Right? You determined the cycle and where to break. You looked back like how the DSM was made, which parameters were being exchanged. I mean, all that kind of information, and you did it. So are
Uh,
the
One thing, sir,
yeah,
that for the tier mark, sir,
yeah,
uh, at present we have the parameters so that we can find out what
yes,
is the which is the thing which we can tear it out and we can continue it.
yeah.
But when it is a DSM,
What exactly
we
is
have
the
there the cross
tearing?
mark. So what what assumption we should take to tear, like it can be tiered properly or in a one go or two go.
Okay.
It should not be a one go.
Yeah.
One
So we
second.
will revisit tiering again. So what is happening is that you have got a
What
loop.
is the meaning of tearing? Why we are doing it?
Okay. Uh, we'll see this. A gives information to B, B gives to D, D gives to C, and C gives to A, right? B gives to D, and uh, okay, there is C also. D gives to C, and C gives to A, right? If I ask you to determine the duration of how long will the cycle take, can you determine it? And you'll say it goes on. I mean, infinity. You'll just go on solving the problem again and again, or you'll be getting closer to the solution. If you get some solution at the D and you move forward, it's good enough, right? I mean, D is your design check. So if it's okay, you move on. If it's not okay, you change the material parameter and move. So if this is a cycle that you determine in DSM, you will need to break it, right? Break the chain. We have been hearing this since COVID times, right? Break the chain. So, so all you need to do is that there is some cycle and you want to break it. So for breaking it, you need to find some tier mark or where you can tier it. And here in this example, we determined that we can tier this, right? So I hope you get an idea of tiering. Now what is happening is that in C you are assuming some material and dimension properties. Then you are calculating your dead load. From that dead load, you are doing some analysis. From analysis, you are coming to design check, and your design is okay because your assumption here was very good, and design is okay. So you move forward, right? Now it's not a loop that you have to be worried about.
Understood.
Yeah. So, okay, now coming to the point, in this case, you knew where to make a tier. I mean, you didn't know actually, but you analyzed it. You went back, you thought how that X marks come or what information is being passed along that that X mark, and you determined where to put the tier. Similarly, it might happen that in questions, you are not given all the information. You are just given a DSM. So, yeah,
Yes.
yeah, you can just break it anywhere. Or let's suppose it happens so that I'll make a I'll make a new cycle.
I could have let it.
So is this? I mean, how many cycles are there? Or let's have it some big one. I mean, it looks quite simple, now. Let's have overlapping cycles. Okay, so how many cycles are there? I mean, just a random example, and this is how the questions are formed for the examination. Huh?
EBCF.
Okay, there is one B C F E, and there is
A,
one,
B, C, D.
yeah, A B C D, right? Two cycles, quite visible.
Yeah.
I mean, is everyone okay with this? I mean, we have got
Yes,
two
sir.
two
Yes, sir.
cycles
Yes.
here.
Two cycles. Two
Yeah,
cycles clearly visible.
yeah. So now if you have to break these two cycles, I mean, even if you break one loop and there is another loop happening, you have to break it again, right? You have to break both the loops to,
Then you look for a common activity which is in both the loops, right? Maybe you want to break that.
yeah. I mean, if you just tear this off,
In this case, let's take B to C, right? B
yeah,
to C if you tear it.
yeah. I would start with a negative example and then move on there. Let's say we break F to E. Now you will say that, okay, one loop is not there, but another loop is there. Now to break this loop, you will again have to cut it again. And cutting it again, you know that you have to go back, you have to find out the parameters, you have to assume something, right? So now, where would you like to assume, or which parameter where you have more confidence? We, in the beam design example, we assumed the material properties, the beam size. Why? Because we were more confident about it. We have been doing it for long. So similarly, either you go for, if you have such information, you go for that tier that you can remove with your confidence, with a lot of confidence, or it doesn't matter much. Or in this case, you just simply do what sir said. I mean, you break in such a manner that maximum loops get broken with minimum tiers. So now what is happening is that B giving information to C, only if you determine what is happening at this information exchange, you can do away with two loops, right? I mean, only at one point you have to worry much and it will sort your problem. So this is how you determine the minimum number of tiers. You find out the common point in the cycles or common points and try to remove them. I hope you got an idea.
Yeah, yes, sir. But we do the tiering only so that we can solve it like any other CPM problem, right? To calculate the duration, etc.
Yeah, I mean, just for that duration calculation, we will discuss in the next session only.
No, that's okay. But we do the tiering only for that, keeping in mind, right?
Yeah,
That's
I mean, we don't want to be get lost in the cycle again and again
right.
and again.
Right. Yeah.
So, any
So,
question? Yeah,
sir, sorry to have one more question.
yeah,
It's more connected with interpretation. See, in the absence of all this RCC beam design, I was very keenly following.
yes,
There, you are applying actually practical thinking because you know so much about the activity. You also know, in a way, what I understood is you are not talking about dependency. You are also talking about sort of strength of the dependency, right? To what
yes,
extent you can assume, to
yeah,
what extent you have your past practices, best practices, which
yes,
will give you an edge, right?
yeah,
And unfortunately, all those information is not captured in this simple mathematical cycle, right? What we are discussing. We don't have access to all those information. So the only way is we have to assume B and C is not such a strong dependent relationship, right? That's the only way I can assume and break it.
Sir, in other words, we are not saying that B and C don't have such a strong relationship. We are saying that all the relationship are equivalent to us. Anywhere
Oh,
we
acha.
break, it is
Okay.
okay.
Hmm. Hmm.
So, uh, as in lectures, ma'am has discussed numerical DSM, where we get the strengths or weights of the relationships, so that you know
Okay.
that if it is a heavy weight relationship or so much depends on that relationship, you are not going to make assumptions there, right?
Okay.
Like coming to the beam design question itself, you know that after analysis you have to do design check.
Hmm.
I mean, you can't avoid this going to
Correct.
check
Correct.
step.
Yeah.
So you are not going to tear it there.
Acha.
But
Right.
when we don't know what all those parameters are, and
Exactly. That's it. Yeah, that is me.
and in this case we have a binary DSM where a relationship is there or it is not there, nothing else.
Okay. 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 That's fine.
Yeah.
Got it.
So, uh, anything else you would like to discuss?
Sir, one thing, sir.
Yeah.
Uh, in that video, sir, we have one session regarding the matrices of binary matrix and the multiplication of the same.
Yes.
So, what we have done right now in the current session, it is a partitioning and the tearing off.
Yeah.
Two things we discussed, sir.
Yeah. So we will
And
come to we will come to matrix multiplication in the next example.
okay, okay.
Yeah. So coming to the next example, we already discussed this, right? I mean, no, we didn't partition this, right? We just made the matrix.
Yes, we didn't partition. We just put the matrix.
Yeah. So do you guys have pen and paper with you? Would you like to do the partitioning in this case?
Yes, sir.
Yeah,
Yes,
we
sir.
can try.
Yeah. So let
Sir, one
me
question, sir.
yeah let me bring you the matrix we made, right? This one we made.
Yeah, yeah. Up to this, we have prepared.
Okay. So there are two tasks here. I mean, the first is that you partition it and you find the cycles. Okay. So I will give you guys a head start. Please start doing this.
Sir, one question, sir.
Yeah.
Sorry to interrupt.
Yeah. No issues.
Like in this example, sir, we have written 5 cycles, sir.
Only five? I guess there must be more. Yeah. Go
Yeah,
on.
no. It's okay. There must be more.
Yeah.
Like we have written 5 at in the screen, which is visible right now.
Yeah.
Just for example, in the process of tearing, sir,
Yes.
like there is a all the cycles we have to tear it off, or only 1 or 2 cycles we have to tear. Is there any condition regarding that?
Yes, sir. Sir, let's suppose.
Like,
Okay. Let's suppose you have to do this in a CPM or PDM manner, or you just want to follow what happens next. Okay. Going and you have to visit each of these activities only once. So, what is happening is that if you leave even a single loop in the network, you will find yourself roaming around, I mean, going in circles over that, right? I mean, talking in very generic terms.
yes, sir.
Even if one loop is there, you will have to worry about it.
Yes, sir.
And it might happen that that loop is very important, then you worry about it, or you say that, oh, even if this loop comes, I can repeat this step multiple times, it is of no such importance to me. So you are not worried about that loop. But in this case, we are going for equivalence, like everything is equal. So in this case, you will have to remove all the loops.
Okay, okay, sir. So we have to tear it off 2 to 3 activities, sir.
Yeah. See here, you can see.
Sorry, not activity. Yeah.
See,
Because like in first one, sir, DG is a 2 cycles,
yeah,
2 way, sir,
yeah,
loop, and the second one is BCD.
yeah,
So DG is not common in both, sir.
yeah.
So in both the cycles, we have to tear it off differently.
Yes. But see here,
That is my
I'm
question.
yeah. See this. Let me just give me a moment. This DG is coming in this cycle also, in this cycle also, right?
Yes, sir.
In 3 cycles. So if you cut this
Yeah.
loop, if you cut this loop in such a way that these cycles also get some break, it would be good, right?
Yes, sir.
And similarly, here CD is coming, right? BCD. here ABCD again. So if you break this loop, I mean break this link, you would find that you can, I mean with minimum tiers you can move on, right? So has anybody partitioned it? Can anybody give me the order? You will see that it is not that simple. I mean determining the
Sir,
order, right?
yes, it's not simple because, sir, the only thing
So
is F is an
there are
empty row. So that's the only thing we can start with.
Yeah,
Other than that, there are no empty rows or columns coming. Hmm.
yeah. So with F you can say that okay, F will go to the front or to the back.
To the front.
Okay,
front.
F will go to the front and rest of all the activities A, B, C, D, E, G, H. You don't know
Yes,
what to do with them right now,
exactly. Yeah,
right?
yeah.
So they become your active matrix, right? We start with F, and here you can see this from the figure also that F is one activity where we have got no incoming arrows. So,
Very clear. Yeah.
so this must be the starting activity. And now you guys know how to find out the cycles because we have got both. I mean, metrics also, and we have got graphical representation also. You can see and you can determine. And number of cuts we discussed. But what happens when you haven't got? Okay, so you guys can do it on your own, right? I mean, partitioning it, you don't need much partitioning here. And number of tier marks, you saw how you can do it, right?
Sir, in the same example,
Yeah.
so can we conclude that we can break C and D and D and G, two tiers?
Yeah. See, you can start with these two tiers, but check again if
Oh, okay.
there are no loops remaining.
Right.
I mean, this is like a trial and error method. This is not the logical way to do it,
Okay.
obviously. But as we can see, I mean, just the psychological advantage of having a graph in front of us that we can see the cycles. I am focusing on this. But what happens when you can't see the cycle? That is the next question. So, okay, just one more time. Do you guys want me to complete this or should we move on where we can't see the cycles?
Sir, just show us the answer. What exact? How to solve such a problem?
Okay, how to solve such problems? Then that means we have to solve it completely. Yeah, okay. Let's do it. Mm, you have got F, A, B, C, D, E, G, H, right? F, A, B, C, D, E, G, H. You start putting the cross marks. Now, let's go back to the cycles we identified. Uh, okay, just help me. I mean, is there some cycle that we haven't written till now? We have got D and G to D. We have got B, C, D. We have got A, B, C, D. We have got C, F, G, D. H, E, B, C, D, G. Anything else?
No, it is correct. We have considered every each and every relationship in the with the crossmark.
Okay, so we have considered it, right? And what are the
Yeah.
tier marks that we can think of right now? If we break D to G or G to D, what do you say?
Maybe D to G.
See here. Now, again, this is quite an interesting way to do it. Let's suppose, okay, you guys will also have these slides again. So, let's do it on a fresh page. Let's do it on this page only. What were the relationships? We had DG, we had BCD, ABCD, then we had a big one, HEBC, DGH, right? HEBC, DG, and one more. What was that relationship?
A, B, C, F, G, D, and B.
A,
D and A.
A, B,
A, B,
C,
C,
D,
F,
no, A, B, C, F, where?
F, G,
Okay, okay.
F, G, D, D and A.
No, but F is not coming in any loop. We saw that F is the starting activity, right?
Yeah, F will not come because that's a starting one.
And there is one loop I'm missing. We wrote 5 loops there, right? Okay, maybe I'll just look back. There is one CFGD we wrote. Let's check. No, F cannot be in loop, so CFGD is not there. Anything else?
Sir, A, B, C, D, E.
A, B, C, D, E. But E is not giving any information to A, right?
Okay, I got confused with the arrow.
Yeah.
Okay.
These are directional arrows. Anything else?
No, I think that's all.
Okay. So with this,
What is the criteria to consider the initial start activity?
start activity. See, right now we are not using any logic. We are just going in a trial and error method. We just pick one activity and we start following the arrows. Like from B we went to C, from C we can go to D, from D we can go to A also, to E also. So B, C, D, we go to E, and again we can come to B. So that means we have got another chain, right? Similarly, we got B, C, D, A, B, another chain. This is not the, what I can say, algorithmic way. Just for better visualization, I am discussing this. So now we have got 5 loops. Let's break the loop somewhere. So let's say D giving information to G, we are assuming this, and we have got CD common. So C giving information to D, we are assuming it.
Let's break CD.
Yeah. So with these 2 breaks, let's try to make the DSM. F gives information to C and G, A gives information to E and B, B gives information to C only, right? Yeah. C gives C, now C doesn't give any information, right? We broke it. C was giving information to D, but we assumed it. Coming to D, D gives information to, D will give information to B, A, E, but not to G, right? So A, B, E. E gives information to B, E gives information to B, G gives information to H and D, right? G gives information
And
to
H. D and H.
Yeah.
And H gives information to E.
H gives information to E. Now that we have got this with 2 tier marks, I'll just put ticks for those tier marks. I mean, this is not the, you already, C gives information to D, we assumed that, and D gives information to G. Now let's partition. Yeah,
Thank you.
you are saying something?
No.
Okay, so let's start partitioning it again. Now we knew that this was our active matrix. F we already know it comes first. I mean F and coming first.
Yeah.
I hope you got the joke. Uh,
Yeah, yeah.
so now let's see. If you
Now G is an empty row and C is an empty column.
yeah, so out of 8 we already placed F. So we are remaining with 7. 1 to 7 we will do the numbering. So G is empty row. G will become 1, right? Uh, and then after G, what will come?
After G, A will come.
After G, A. No, A still has something.
Then C is empty column.
Yeah,
Okay, we can push it to the end.
C is empty column. So we push it to the end. So C gets the number 7. Now, now we have got again B as empty column, right?
Sorry, yeah, B as empty column.
Yeah. Oh, I just okay. I am using the eraser also. What is?
Sir, sorry to interrupt in between, sir.
Yeah.
One question is there.
Yeah.
Like we have done the tiering, sir.
Yes.
Uh, cannot we go with the making it a active matrix and do n times the multiplication of the matrix, and we can have the sequence? It is
Uh,
the same process that we are doing now, or because it is little bit confusing
sir.
between tiering and this one.
Yeah. Actually, that is what I've been repeating. That this is the kind of visual way I want you guys to visualize what is happening before I go on to algorithmic. Like from the starting itself, we first tried to visualize and see from the graphs what was happening, and then we went to the even for partitioning we saw how it was coming in order, and then we saw how following the algorithm for partitioning we are getting it the lower triangular matrix. Similarly, all I am trying to emphasize here is that we see what is happening and then we will move on to algorithm for tiering.
Okay. So uh, the the process which we do in the algorithm with the binary matrix multiplication,
Yeah.
it is the same process we are doing it now, or it is a process afterwards which we do the tiering.
uh, okay, so okay, so I will move on from
Because,
here because
because in multiplication also, sir,
yeah.
we get the active blocks in multiplication after by clubbing the uh, by merging the cells
uh,
in which the diagonal we have non-zero value, we club it. Then that is the process, no?
Okay, sir. So let's do one thing. We will go to the algorithmic way right now. We'll see what is happening. Okay. Now coming to this question. For the given DSM, perform the partitioning operation, find the active block, and find the cycles. So just by looking at this DSM, can you guys tell me what are the cycles here? You will, I mean, you will have to stress, but you can find out, right? So let's do it step by step, like what is supposed to happen. So first of all, partitioning operations. Partitioning operations means looking for empty rows and columns. This T, okay, I won't even be putting the cross marks now. T is your empty row, so T will come first. Any empty column, yeah, U becomes your last activity. Anything else now? Okay, this will be quite clear. Any other empty row or column?
I don't have to do
No.
anything.
No. So I guess then this is, if you had to make your active matrix right here, you would have said that this is your active matrix, right?
Yes. Yeah.
Now this is your active matrix and there are so many loops present that we can't even determine. I mean, we don't want to spend some mental energy to do this. So what we can do right now is we take it to matrix multiplication. So I will bring, I'll take you to MS Excel because that would be quite easy, right?
Yeah.
See, yeah.
Uh, okay, just let me find out where I have this question. Okay, is this the same matrix that we were discussing?
Yeah, yeah, yeah.
Right. So the next step would be to all you all guys can see my screen, right?
Sure, sure.
So what I will do is I will start creating a copy to this sheet and move forward with this. So now what is the active matrix? You found out that this is your active matrix, right? Removing the T and U. So
Sir,
if
is there
th-
difference between active matrix and active block?
No, 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 no. These are like the same words interchanging. I mean, if we have a bigger matrix, then it would be better to say that, okay, this is an active block in that matrix.
Okay.
Yeah. So with this active block, now we don't know what loops are there. So we will start putting zeros and ones, converting into a binary matrix. Okay. Uh, So this was your matrix. So what you have to do is you have to put 1 for every cross and 0 elsewhere, right? So we will put it. This can be, I mean, this step can be quite long.
So this can be done with control F. We can replace it with X marks with 1 and blank with 0.
Yeah, let's, I mean, if we have to do only with this, see, the whole Excel sheet is blank na, right now. Or either I will have to put some formula for these selected cells. But let me do it manually. We can do it manually also. It won't take much long. Okay, so now we have converted our active block into binary matrix, right? Everybody agrees?
Yes, sir.
And you can see.
Yes,
So,
sir.
so now let's do matrix multiplication. That's the formula, right? MMULT.
M mult, M mult.
Yeah, for this.
Yeah, and you can give the same, right? Yeah.
Yeah. So now you have got something, but how to interpret it? Can you guys all see this matrix?
Yeah.
Yeah. So all the diagonals in your active block were 0 But when raising it to power 1 only, I mean squaring it, right? We squared it. This is n
Oh,
square. You got once 1 in some diagonals, right? Diagonal elements.
yes. Yeah.
4 times q, r, w, and s.
Mm.
Now, if you look into your binary matrix again, uh, just pick any of these. If you pick, now this is how your matrix multiplication is helping you. At n square, you could identify one element. If you are getting non-zero element, that means that that activity is in a loop. Now you have got q, go to q
Okay.
and
Yeah.
start looking.
Okay.
Q gives information to x, q gives information to v, q gives information to s. Quite a heavy activity, but let's see. If it gives information to x, and x is giving information to w, w is giving information to q, this is one loop, right?
Yes. Yeah.
So q is giving information to x is giving information to w, and w is giving information to q again, right?
Yes.
So now you see what we did was we just identified by matrix multiplication that okay, this element or this activity is in loop. We don't know which loop. We still have to find out the loop, but we got a starting point. So this algorithm helped you, like you don't have to traverse all the activities. You know, identified okay, you have to start with q. From q you got one block, right? Q, w, and x, right? Wait a minute. Yeah, qxw. Did you guys get what we have done or what we did right now, right here?
Yeah.
Yes,
Yes.
sir.
Yeah. Clear.
So we identified one loop, one block. We made another block, right? qwx, qxw. So uh, I will go to this sheet again, and wait a minute. This doesn't look good. Uh, Clear formatting. Is there some way to clear the formatting? Okay, I'll just try and delete. Yeah. Okay. So T and U are still at the end, but sir, I want you to repeat that block. We got QXW, right? Remaining
Q.
activities. Yeah.
Q.
Okay, XQW. I would go in, or QXW, whatever you
No.
say.
Q. QXW. Yeah.
QXW. Then rest of the activities in the same manner. P, R, V, uh,
Yes.
yeah, S and U.
U.
Okay, so let's start putting the cross marks. T gives information to P, T gives information to W, right? So
Yeah.
T gives information to P, T gives information to W, but we don't have W, we have a block. So if T is giving information to W, that means it gives information to block QXW,
XW. Correct. We have to put an X there. Yeah.
to X here. Now coming to QXW, X gives information to P and W. So P is outside the block.
Yeah. So P.
Yeah.
But
Now Q gives information to X, V, and S.
so V and S.
So V and S again. Then
Then the
W gives information to Q and R.
so R.
R
Okay.
will come. Coming to P, P gives information to R.
R.
Uh, R,
R. R to Q and W.
Q, and W. So it's just giving to this block.
Yeah.
V is giving
V to
information
S.
to S. S,
S to Q W. That will come in the one block.
yeah,
Then you have U. Yeah.
and we have got U. And
Yeah.
U is not giving information to
U
anything.
is not giving. Yeah. It's not
Yeah.
part of the active. Let's say.
So now our new matrix with this block looks like this. Okay, or or should I say that we shouldn't talk of T and U? We already determined that they come, right?
Yeah, I was about to ask you, do we have to do T again? Consider that's
No, no, we don't have to consider. I mean, we just work on the active block now.
T. So then we start from QXW to S only. Okay.
Yeah. No, I just wanted to emphasize that while putting the cross marks, you take the whole block.
Aha, side.
Okay. So now your matrix under consideration becomes this.
Any more partitioning because no blank rows and columns.
No blank rows and columns,
So
right?
does it mean that we assign values 1 and 0 and start the process again, or
Uh, sir, you tell me.
because we still need to find the loops and other thing, no?
Yeah, we still need to find the loops. As you can see that here, yeah, diagonal element is coming non-zero.
Yeah.
Yeah, sorry, diagonal element is 0 still. But yeah, no empty rows, no empty columns. We don't know what to do.
What?
So the best way would be to move forward with matrix multiplication again.
Uh-huh.
So control V. Again, I am not using the formula. Just check if I am.
Yes. Yeah. I'm following 0. 1 0 0
First
0.
process which we have done, sir.
Yeah.
The first process which we have done, we have formed the Q, X, and W.
Yeah.
We have, so in that process, have we to find out the loop in the matrix only, or we have to do it with the multiplication?
Okay. See, this was the multiplication that we got, right? This was the multiplication, right? Matrix multiplication. Second one. Can you see it on the screen?
Yes.
Yeah. So if you see that you have got 1 here, but for the remaining X and W, you are not sure. With W, you are getting with X, it's still 0. So this actually only gives us the starting point. And from that starting point, we have to go back to our active block and look for the loop.
But in matrix that multiplication, we see for the diagonal value, no, sir?
Yeah.
The diagonal non-zero value, but here we are not seeing the diagonal value. So it is the same process, or we are clubbing it for the loop? Because in matrix multiplication process, sir,
Yeah.
we go for the square matrix and multiply the matrix up to n times, and denotes the number of activities for the
Yeah.
active block.
Sir. Yes.
So
Yeah.
as per my knowledge, sir, I am not sure about it. It is my just
Okay.
the thing. That's
So
what I'm asking you, sir.
yeah, what is
So am I
happening?
right at this point, or-
Yeah, let me start. Okay. What is happening is that you have an active block and you want to find out what the cycles are, what the loops are. Now, for finding out the loops, as we see that in this active block, we only have 6 activities. It could have been 200. It could have been a huge number. Now you need some place to start with. I mean, in the starting, you don't even know if this activity is in a loop or not. So what you do is you square the matrix once. You don't go and squaring it again and again and again till the end. You have to go step by step. So
Yes, sir.
so first time you make a binary matrix, you square it, n square. From n square matrix, you determine that okay, this activity Q, it could have been, we could have picked R, we could have picked W, we could have picked S, just for this example showing you, and it would have given you the same results. You can try it. So here I picked the Q. From Q, I went to the matrix again, the original one, found out the loop. Once I found out the loop, I made it into a block QXW and made the active matrix again, and as you can see that there is no further partitioning that can be possible. So you made the binary matrix again. Can you follow it till here?
Yes, sir. Yes, sir.
Okay.
Yes.
So till now, what this You had already squared it, right? So do you think we'll be cubing it right now?
Pardon, sir?
Uh, okay. So let me.
After the
Yeah,
after that, we have to again go for the partition work,
yeah.
partition process for seeing the empty rows and empty columns. And after the partitioning, again we have to go for the multiplication for the active matrix.
Okay. Sir.
Is it a correct
Uh,
process, sir?
yeah. Let me just add here. It might have happened that when you squared it, okay, you squared it and you got some non-zero diagonal values. It might have you saw that x is in cycle, but you are getting a zero diagonal value, right? After squaring it, you agree? I
Yes,
mean,
sir.
so but still it is showing zero. So it might happen that if you square the matrix, all the diagonal elements are still zero. So you don't know where to start, but you know that there are loops because you couldn't partition it well. I mean, you couldn't partition it fully. So you know that there are loops, but having a zero diagonal value doesn't mean that in n square doesn't mean that it cannot be in a loop, right? So if all these values were zero in n square, we would have cubed it and saw if we are getting any non-zero diagonal value and picked that and looked for loop. So you understood why they say that you can go on squaring it, I mean go on multiplying it n times or n minus 1 to be
Yes,
exact.
yes, sir. Understood, sir. Sir, one query, sir.
Yeah,
Uh, like we have done this, this is a n square.
yeah,
Okay, sir. When we will do the n cube,
yes,
n3, so n3 will be the multiplication of this the outcome or this outcome and this original matrix.
yeah, definitely. I mean it's just a simple multiplication. This is n square, so n square into n would give us n cube.
Okay, so we have to always multiply with the n only,
Yeah,
not n square.
no, no. I mean
Okay,
it would be n square into n,
okay.
yeah, to get n cube, right?
Uh, Sir, in the example we have done earlier, I've done 10 days back, I'm not remembering it. I
Yeah,
have to recall it again.
yeah,
But I think like in this, in n square, sir,
yeah.
W and S are having the diagonal value 1.
Okay.
So we can club it, W and S, a loop is there.
See, I won't always. Okay, you you found from the example you know that there is a loop between Q, W, and X, right? I mean,
Yeah.
we can see, but just by looking at the non-zero diagonal values in n square, can you say that? Can you say the same thing? I mean, see
No, no,
here, X
from the
is
n
zero.
square matrix, from n square matrix, we will get the hint that this activity will be in a loop.
Yeah,
So we will check it out the activities related to Q. What are the inputs and outputs? According to that, we can find the loop for that.
yeah,
It is one way. It's a
yes,
hit and trial method.
yes,
Uh, but in the example we have done, sir, it is okay. But we can club it W and S also,
uh,
like both in the
sir,
sequence, and W and S have a non-zero value in the diagonal.
sir, that's what I mean. That's what I'm saying. Uh, See here, Q and R have non-zero values, right?
Yes, sir.
Now, can you club Q and R? Q gives information to R? No. Does R give information to Q? Yes. But this is not a loop, right?
Hmm.
I mean, by the same logic, we could have clubbed Q and R also.
Okay.
But we cannot do that. I mean, we see that this is not a loop. This is just giving us that, okay, this activity is in a loop. That's it. Is in how many loops? It can be in one loop, it can be in multiple loops. We are not even getting that clarity. And we are not getting exactly that, oh, if n square and diagonal value is 0, then it is not in a loop. No, it is just giving us a starting point.
Okay.
Yeah. So
So
yeah,
when the diagonal value of n square is non-zero,
yeah,
so we have to check it out for the loop for that
yes,
particular activity, and the loop can be more than one also.
yeah. It can be more than one.
So how to find out for that one? If the
So
loop is more than one, sir, like in this example we have taken for q, x, and w.
yeah,
So just for an example, if there are two loops related to q, there is q, p, r, and v also. Just for an example, sir, we are taking.
no, sir, you
So
don't need an example. It is directly there. I mean, Q gives information to S, right?
yes, sir.
S
Yes, sir.
gives information to Q.
Q give information to S. S give information to Q. Yes, sir.
Yeah. So you see that Q is in two loops right now, right here in front of you. I mean, not. Yeah.
Yes, sir. Yes,
So,
sir. Yes, sir.
so what we are doing is that we are we will find out it. We will find out that Q and S are in a loop a lit. I mean, somewhere ahead, not right now.
Okay, 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 sir. Okay.
So what we got is we got one starting point, we got one block. I mean, we made QXW, and again we cannot partition it. So we will again square it and go on till we can finally get some partition matrix, or we can make active blocks out of this. I mean, are you getting this point? What is happening?
Yeah, 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 yes, sir.
Yeah.
Yeah.
Uh, the only reason, I mean, I should apologize because this was what exactly taught of having n squares. I mean, but I didn't want to focus on this part because it kind of loses the visualization part. So
Exactly. The concept was clear now only. Earlier, I was not having the clear concept of a non-zero value of a diagonal in an n square matrix. Now I am clear about it. That if a diagonal if a diagonal value is giving a non-zero value, it means that activity is in a loop.
yeah, and it also makes that you don't have guarantee that if you have non-zero, I mean zero at diagonal value at n square, it cannot be in a loop, right? It is just giving you a
Yes.
starting point.
Okay.
Okay. Uh, I mean, we are already extending this session. Any doubts regarding this? I mean, I will share you the material uh, today by today itself, so that if you want, you can practice it and we can discuss it. This last example is quite vast. I mean, you will find it very big.
Yeah, and then maybe we will try out the last example and then post it there and you can check it actually. It's a good thing.
Yeah,
Maybe
definitely.
let's do that.
Okay. So,
One more thing, sir.
anything? Yeah. Any question? Any clarification you would like from my side?
So, like the examination for this topic is on 26th of March 2023.
Yeah.
So, what is the pattern of the exams? Are there any the numericals will be there, or the theoretical part will also be there? So, a little bit of like a pattern of the exam. Like it is
Okay.
my first course of NPTEL,
Uh,
so I'm not sure about it. So, for that only.
See, the basic doctrine is that we will be following. I mean, the exam would be more or less similar to your assignments. So, what you have solved in assignments, similar questions you can expect there. Yeah, there might be something out of those. I mean, you're also expected to learn something outside or something extra. So yeah, those questions can come, but more or less similar to the assignments.
Okay, okay.
Yeah.
Also, sir, I have noted down some questions related to this topic, but at present I was not in the office because that notebook is kept in my office drawer. So,
Okay.
in the next session, surely clear my doubts related to this topic, sir.
Yeah.
I've noted down, but
At presently, I'm out of the station,
Yeah.
so that note is
Uh,
not with me.
so you can
So
always, message in the discussion forum and mention that this is related to live session. So I will reply it there. I mean, if you don't want to wait for a whole week.
not unsure. Okay, sir.
Okay.
Thank you, sir. Thank you.
Thank you. So, anything else related to what we have discussed in metrics till now? We didn't touch the iteration modeling part. We will see it in the next session only.
Sir, I would like to ask, squaring up is whatever the techniques we apply in matrix multiplication or squaring, is
Yeah.
it same or something different, or it is a binary squaring?
It's exactly the same of matrix multiplication that we have studied in our schools. Just the numbers are zeros and ones.
Okay, okay.
Yeah.
Thank you, sir.
Uh, so I think we can end this session for today, right? Thank you, everyone.
Th-
Yes. See you again.
Thanks a lot, really.
Okay.
We'll see you next Friday. I think
Yeah.
that's the last one.
See you all next Friday.
Thank you.
Thank you. Thank you,
Thank you.
everyone.
Have a nice weekend. Bye bye.
Okay, so I am ending this session now. See you next week.